Hello, hello. Good morning,
Morning,
everybody. Good afternoon.
afternoon.
If you're east, good afternoon. If you're west, good morning. Of course, that's all relative from my position. If you're east of me, then even more good afternoon, because it'll be probably 3 p.m. for you right now. And if you're west of me, and you'd have to be, well, you're going to be probably 3 hours or, oh no, not 3 hours. We're not in daylight savings yet. It'll be 2 hours, or you're 4.5 now, or 5.5, Ganesh?
I think
I
I'm
don't.
4.5 behind you. You're in Australia, right? Yeah, yeah. Of course, you're in Sydney.
No, wait.
Um,
What time is it for
yeah.
you now? 8:30.
For me, it's 8:30
Yeah, four and a
8:30
half.
a.m. Yeah, four
Yeah,
and a
yeah,
half.
yeah. So you're 4.5. Yeah, and then when we go daylight saving, you'll be 5.5. Yeah. So
Nice.
that happens next month.
Oh,
Mm. Fun fact
can
is that
everybody hear us? Say hello, hi. Maybe some few of you.
yeah, do that. Say hello, hi, something. Hello.
Oh, there you go.
Yeah. All right. Very nice. Um, do you know we go into something like 5 time zones when we hit summertime? Australia splits up
Really?
into like five different time zones. Something, I think it's 5. Okay, I can work it out, right? So under normal circumstances, we have 3 time zones in Australia. Okay, we have Eastern time, we have Central time, and we
Mhm,
have Western time, right? So Perth is like 2 hours behind, but then
mhm.
South Australia and I shouldn't say Perth, I should say Western Australia, but Northern Territory and South Australia are half an hour behind the East Coast, and then the East Coast is all the same. But when we go to
Mm,
daylight
mm.
saving, the East Coast splits. Like Queensland doesn't change, but New South Wales and Victoria and Tasmania, they all go forward. So we end up with a new time zone. So instead of 3 and we all shift, most of us shift, but Northern Territory I don't think shifts, and Queensland doesn't shift because they're far enough north where they don't have to. So I think then we end up with 5. Guys, you correct me if I'm wrong, guys, but that's I think we go from 3 time zones into 5 when daylight saving comes around. So yeah,
But
fun
you know
fact.
what? Australia, I think complete east to west is somewhere around like 4,000 kilometers.
Yeah, about that. Yeah,
Yeah, it
it's
is.
a
It is somewhere around 4,000 kilometers. Yeah,
it's a five and
and you
five and a
have
half
like,
hour flight.
and then you have like three different time zones. And India, again from east to west completely, is about 3,000 kilometers, right? But we just have one time zone, just one.
and it's and it's like on the half hour.
Yeah, yeah, exactly.
All the other ones are on the hour.
Yeah.
Cool. All right, I think probably yeah, I think we're good enough to get started. Looks like we have most of our people online. Thank you very much for joining, guys. I mean, we had over 20 people that signed up just before 1, which is like, wow, like just before starting. So it's like, it's
Just before
pretty
starting.
cool. Yeah. So yeah, if your colleagues are supposed to be on this call and they are not here at the moment, make sure you ping them, remind them that they should be here, right? We are moving over to the dark side today, right? So this is the forgotten part of the stack, right? It's the dark side because you know why? Nobody ever sheds any light on it, right? We don't have any visibility over there, so we want to get some understanding of what that customer is actually doing, right? When they're interacting with our services, right? So we're going to be focusing mostly on browser today. And yeah, if we get a chance, we'll do a little bit on mobile as well. But it's predominantly browser that we're going to be covering. Let me grab some slides and bring them up. Okay, so you guys should see my screen okay. I think.
I can. Yeah.
Okay, cool. All right. So, a couple of things we need to talk about, right? From a front end perspective, okay, our focus is really on three key things that we're looking at here, right? So we want to make sure we have appropriate availability, make sure we have functionality. That's a key one there, because that one often gets missed. And obviously we want performance as well. Okay, so in a very, very simple understanding, yeah, is it up and running? Is it working right? Because I don't know about you, but I've had this happen to me many, many times where I hit a website, for example, the site's up, it's running, it seems to be responding quite fast, it's doing what what it seems to do. But as soon as you start drilling down and you want to then click on some of the services that the site offers, things are broken. And I found this happen a lot of the time, and that's why I generally, I would suggest that functionality is the thing that we tend to miss, right? We've been doing availability forever, right? I think actually most of us are pretty much across being able to determine whether something's up or not, right? It's a whole different story to determine, well, okay, I know that system is up, but what service is it supposed to be providing, and is it successfully doing that? And also, is it doing it within a time frame that's acceptable? So availability, functionality, performance, that's the thing that we want to focus on today. So we're going to do that from a browser context. Now, just here, this is mapping those three key things into some of the things that we can look at in New Relic to determine whether or not these things, have been met or not. So, for example, things like throughput drops, right? I quite like this actually, because a lot of the time, and I'd be interested in your ideas on this as well, Ganesh, but I feel like for a lot of the time, we tend to think of availability as 100% or 0, right? We're either, it's like an on or off thing, right? We're available or we're not available, right? But what if we're partially available, right? What if, our service is distributed and some of them have become cut off somehow, right? Often it's we either are or we're not, but I don't think it's quite as simple as it just being this, on-off situation. And there's many circumstances where a portion of your customers might be disconnected from you for some reason, and or even, I mean, maybe you're disconnected from your customers, so your systems are online, but they're not exposed, online but not exposed. You'll see a throughput drop, and depending on how not exposed they are, it may drop to 0, but it may just drop off quite dramatically. So it's an interesting one, and I think it's a not necessarily something people think about.
I see few SRE teams where they say, just like how you mentioned, either if you're up and running, or if the availability checks pass, they say we are 100% available. But in this world where you do not have a monolithic system, it's all microservices, right? There's a possibility that your authentication service is working, but your product search is not working. It is still an incident. It is still a problem with that your customer is facing. So I see few SRE teams that what they do is they report a 99% availability, 99.96% availability, but also report a partial downtime of like probably 1%. That's where few of their services are not working. And the one good way to look at this is your application is up and running, so your customer is able to access your system, but he's not able to do everything that he wants to do, right?
Mm.
So that's an incident, partial downtime. Whereas if your entry point into your system, like your website URL or your authentication is not working, that's a complete downtime for me.
Yeah, I agree totally. And that will actually take us across into the realm of functionality, which we'll talk about next. But yeah, it is still a case of, well, the service has been denied to me, so I go to a site that can provide 5 services. 3 of them were working fine. The other 2 are not there. Yeah, is it an availability thing? Is it a functionality thing? It's actually both, right? We are missing certain functionality. The system is available. Some of the services that the system offers are not available. Um, I quite like the throughput one because I think generally when we talk about things like throughput, often people will look for throughput spikes as maybe being something that is of interest to them. But what if it were to spike down, right? So that's the thing. A spike up could be a problem. A spike down could also be a problem, right? And I've seen many places where, yeah, we'll put some alerting in place on if our throughput goes above a certain level, but there's no alerting to say, well, if throughput goes below a certain level, it could indicate a completely different problem, which it really could do. So it's something to think about right there. Now, we do have, and next week, guys, we will be getting into this topic here, which is synthetics. Okay. This is, we've got some very, very simple availability alerts that, you guys can do. You can run them from 20 different locations around the world. And it's essentially allowing you to run an HTTP GET request at any URL of your choosing, right? And that gives you just very, very basic, simplistic availability. And, it's available to you right now in New Relic. You want to learn more about it, that's next week. Also, within synthetics, there are automatic. So these are automatically generated SLA reports, right? So you essentially just aim the monitor at a URL, and it will start tracking it on the frequency that you define, and it will obviously record how many times it was successful and how many times it failed, and it can then easily give you an SLA report that comes out of that. So yeah, there are a couple of things that we can look at from an availability point of view next week. This week we will be looking at availability from a browser point of view. So we'll come in and have a look at these charts in a little while. But a couple of other things that we can look at from now our second concept, which is the need for functionality, right? Okay, site is up, it's online, we are testing it, it's responding to HTTP GETs, everything seems good, but it doesn't do everything that it's supposed to do, as we just mentioned. So things like JavaScript errors can help us with functionality related problems. Now, how are we going to see a JavaScript error that pops up inside a browser, inside one of our customers' computers? How are you going to see that? Right? If you don't have a mechanism to capture that and send that data to a place where we can analyze it, it's going to provide an annoyance for the customer, and it's never going to get diagnosed because it never gets reported. You don't even know that the thing is generating an error. I mean, maybe you'll pick it up in your internal testing. Okay, but what if you're running tests across maybe 2 different browser types at certain versions, and you realize, actually maybe your customers aren't using that browser. They're not using those versions browser. So your testing may not be in line with what they're actually using. So they're experiencing all these errors that you're not finding in your testing because you've got a different, you're using different tools than what your customer is using. So within New Relic browser, we do capture JavaScript errors that are reported in the browser, and we will show you some of this in a little bit. And this can really help you to determine whether or not the customers are actually experiencing a functionality problem. So these are real errors, right? Now, again, we also have synthetics where you are able to set up scripted browser monitors. So the idea behind this is that we proactively find problems really before the customer finds them. And hopefully we can eliminate those JavaScript errors before they even happen, okay? Because we're proactively testing, but you never know. And sometimes they'll be using some weird different browser, or they'll be clicking somewhere where we didn't anticipate. Errors get thrown. At least they won't be lost completely. It'll all get sent in, and we can then work on it and understand, okay, what's the highest number of JavaScript errors that we're experiencing by class? Where are we experiencing from? And you can start working on things that are going to give you maximum value in minimum time. All right. And obviously the last one is, well, we've talked about alerting already. I think you guys do understand that alerts are quite important. And the only thing I really want to mention here is that we can alert on synthetics, as it says. We can also, obviously, we can alert on browser as well. So if you wanted to define, throughput drop alerts for your browser experience, you can do that, right? And you can also put, error rates from the browser, that kind of thing. All of that stuff is possible. So have a think about what things are going to be really important for you in terms of needing to address. And if there's not an out-of-the-box alert that you can just easily define, there's almost certainly a query that you can write that will allow you to capture the data that you want so that you can alert against your query. All right. Anything you want to add, Ganesh?
Nope, you're good. Covered availability, functionality. Again, synthetics is my favorite topic because I've had a lot of discussions with customers who never use synthetics. They never realize the potential of it. Whereas they keep saying that, hey, we are good with monitoring the error rate of our transactions on our APM, and we're good with that. But I was like, okay, when you get a transaction to your service, and if your service is failing for some reason, that's when you'll get an error. But how do you know if your service is completely down? Right? A lot of customers do not realize the potential of synthetics. That's where I get an opportunity to educate them and then say, hey, synthetics is not just for this, but you should actually use it for this one. And yeah, I've seen customers who leveraged it and then got a great benefit of it.
Well, not only that, but I mean, if we're talking about synthetics, I mean, the other thing, the other discussion that sometimes comes up is, do I really need the two, right? Like if I am actually monitoring my real-time user, my real-time user base, right? These are my actual customers, and I've got agents inside the browser, so I'm seeing what they're really doing. Why do I need to simulate that and set up synthetics as well? Like, isn't it overkill, right? So this is the other discussion that's often had, and I'm sure you got a couple of things to mention there, because I love synthetics as well.
Yeah.
But in terms of the difference between the two, right?
Go ahead.
No, I was passing over.
Yeah. So when it comes to the difference between synthetics and browser, just like how I mentioned previously, right? So when the customer is actually doing something, and if he's hitting an error, that's when your error gets recorded. But are you proactively making sure that everything is going to work when a customer is, even before a customer tries to do that? That is when synthetics comes into picture. The proactive monitoring is like the basic one for synthetics, right? So using synthetics, if I have to take an example, one of the e-commerce customer who was about to go on a specific category of product. Right. So when they try to test this, the sale is actually going live at, they wanted to make sure everything is working fine. So that is when they had to set up enough synthetic checks to make sure that, by even before the sale season, everything is working fine or not. So yeah, I mean, you can use it in multiple ways. You can use it in multiple ways. My favorite one has always been not just the ping checks. For me, it's always the scripted browser. I really like that.
Yeah, I think look, this isn't the only industry that does this kind of stuff, right? I mean, just about every other industry, when whatever product it is, there will be a lab testing component that's done, right? Which is to say, is the product
Exactly.
fit for purpose? Does it do what it is designed to do within the parameters that it is supposed to function? That's the lab testing, and it's to determine that the design is sound and it does what it's supposed to do. Then there's obviously the real world data analysis. You can't just go with one and not the other. I mean, imagine in that like aviation industry, for example, right? You say, oh, we've got the lab testing, right? Like, no, we've got the wind tunnels and everything. We don't need real-time telemetry. We don't need to understand how the planes actually fly. We've done the testing in the lab, man. We're good to go, right? It would be crazy, right? Nobody does that, right? In the same way, you wouldn't go in reverse either. You wouldn't be like, oh, let's just whack this thing together and see how it flies, right? We'll just get the real telemetry and, oh, well, if it falls out of the sky, we'll just, we'll build the next one a bit differently, you always need the two. Right? And in software, I mean, I'd say that, things aren't going to fall out of the sky, but actually it depends on the software, right? So with some software, things will fall out of the sky if it doesn't work properly. So
Yeah.
that's the point. We have to have the two. It's not a case of, oh, but I know what my customer does, therefore I don't need synthetics. It serves a different purpose. And you can have synthetics and it's fantastic and it'll tell you that things are fit for purpose, but it doesn't tell you what your customers are actually doing with your software. So
Right.
put the two together to get a complete picture of what's going on, just as we do in every other industry, right? So you really need to do the two. Now, our final our final concept that we need to focus on is our performance, right? So things like page load times, which were historically our go-to benchmark for how things are performing in the real world. We're going to get into this in more detail. I'm going to show you why that's just so 1990s when we don't live there anymore. Like we're in 2020s now. We got totally different benchmarks that we look at. You can still keep looking at page load times if you like, but there are other things that give us different indicators. Some might even say better indicators of how our site's actually performing. All right. We talked about AppDex. Okay. Don't discount AppDex from the front end perspective. You guys now know the value of AppDex from an application standpoint. Imagine if you were able to, because we already know we can level set all of our apps, right, with the same scale, but we can do that for the front ends of each one of these as well. So, our sites are going to be very, very different, right? One site may load up in 2 seconds, another one might take 8 seconds, but both of those things could be by design. AppDex will allow you to put everything onto the same scoreboard, and your site that's loading at 2 seconds because it's supposed to will get a good AppDex score. The site that loads at 8 seconds and it's supposed to will still get a very good AppDex score. So it is still a good baseline to use. Things like optimizing your front end code, managing page bloat. Now this, I think I mentioned this actually in an earlier session as well, and you just mentioned something similar, Ganesh. We're talking about errors, right? And we're saying, oh, but if I'm looking at the transaction errors in my app, that's enough. I don't need to see what's happening in the browser side. It's like, well, the same deal goes for performance as well. People think that. People think, but if my app is running fast, well, I don't need to see how it's going on the customer side because like I can see that my app is performing well. It's like, yeah, but you don't know how it's performing from their end, right? And the example I love giving is, let's say, you're a developer, right? So you're a developer and you got an app and it's running at average 500 milliseconds, okay? And maybe you've been given a directive to improve the transaction speed on that, and you can't necessarily think of ways to optimize that code any further. But perhaps one thing you could do would be you ship more of that code across to the browser, right? So you say, okay, well, you know what? Rather than crunching the numbers here on the server side, which is just going to push me closer to that 500 milliseconds, I can shave 100 milliseconds off the transaction by asking the browser to do some of this work on its end. Cool. I go back to my boss. I got a 20% measurable increase in, well, decrease, increase in performance, decrease in transaction time. Cool. Hey, boss, I went from 500 milliseconds to 400 milliseconds. He goes, that's fantastic. That's great. And then sales drop off a little bit from the e-commerce site that you've just optimized. You say, what's going on? Well, actually, page load went from 1.5 seconds to 2.5 seconds, right? There you go. You're now taking a second longer on the browser end because that's not optimized equipment to run whatever it is you're running. So, it took longer, and overall transaction time, which should be measured from the browser, the overall transaction time actually took a lot longer, even though transaction time as measured within the app was quicker. And a lot of the time that gets missed.
Yeah. One good example that I can tell you is one of our customers is they're a fintech in India, and that customer have a website that's performing anywhere less than 3 seconds page load time, and they're pretty happy with it. So, and they're making sure that it is working fine in India. All the customers are using the website less than 3 seconds of web page response time, all good. So now the founders actually traveled to the US for some investment, and they were trying to show the website to the investors. The page load was horrible. It took 10 seconds just to load the page, right? And then for some reason, it took 10 seconds, everything managed, and they went to China for another investment meeting. The page never loaded there in China. So that is when we realized, okay, making sure the website is working in India is good, but where else should it also be working properly? And that's when the customer started looking for different options, identified a proper CDN, implemented it, did all possible optimizations for their web pages, right? And since then, the synthetic checks have always been from 4 different locations across the world for that customer.
I love that story, man, because it highlights a number of things, right? So, because you're talking about the synthetic side of it as well, saying, okay, now we're testing from these multiple locations, right? Which is, obviously, if you've got customers in multiple locations, you want to be testing from all of those different places so you can get a better idea of their actual experience. But again, it's the real world data that, one thing we're going to get from browser is we're going to find out where our customers are consuming our services from, right? Where are all these requests coming from? If you're just looking at the app itself, it doesn't capture anything like that. It's saying, got a request, replied to request. That's it. But, within the browser itself, and we're going to look at some of these tables, right? Like we'll get to see what city the transaction was initiated from, right? What country, what region, all that kind of stuff. And it's there. We've even got out of the box charts in the product that, show you these really nice maps of where everybody's coming from. So I got one or two more things to show you. So yeah, with regard to our front end problems, these are things that we want to look for, right? drops in throughput, things like spikes in our timings. There are other things we're going to look at as well, like gaps between time to first byte and document object model loading up, right? So that gives us an idea if it's a front end problem or not. Like if there's a really long time between we got some info from the server, but it's taking a really long time to display anything on screen, then that's sort of all in the front end space there, right? Because this, the server could have responded very, very quickly. That doesn't necessarily mean that we're going to start seeing information appearing on the page very, very quickly. They don't necessarily correlate. So there's some things to look at there. Apdex we talked about. JS errors, I'll take you into that page in a little while. And of course, don't forget our percentiles are very, very important as well. And Ganesh highlighted that just now on the story that he was talking about, because if you've got a site that's perhaps only servicing local customers, then your requirements from a front-end analysis are going to be quite a bit different than if you've got a site that has a global customer base, for example, right? Does it really need to be available from everywhere and have good performance from everywhere? Or, are you a business that's located in Australia and you only ship your product to Australia, for example, or your service is only national or regional? So that will have an impact on things like the percentiles that you're concerned for as well. Even in regard to us, for example, like New Relic, right? New Relic has to ensure that performance is good all the way up to the 95th percentile, right? Because they've said, for us at New Relic, right, with our telemetry data being located in Chicago, right? For us here in the APJ region, we actually kind of fall into that 95th percentile because we're far enough where, for example, if our region didn't exist, they wouldn't need to factor in the 95th. They'd say, okay, we can be a bit more stringent. But because they have a customer base everywhere, they have to go, no, we need to factor in all the way up to there. So yeah, know where your customers are going to be calling in from, because obviously that will have an impact as to what it is that you really need to be optimizing for. And we're gonna get a little bit into this as well. So there are a lot of different timings that we can capture from the browser, right? They're all well, here's two of them. There's two right there. First contentful paint. Okay, you can see there the difference between them. First paint essentially means the first thing that you see on the screen. When we talk about browser, I don't actually have a slide on here, but when we talk about browser, we typically talk about there's a series of questions that the customer will ask as something's loading. And if you guys think about it, you probably do ask these questions to yourself. You may just not word it that way. But the first question that everybody asks is it happening? Right? So if you click a link or you type a URL and you hit enter, something, right? You want confirmation that something's happening. Otherwise, you're gonna probably click the link again, right? Or you'll check your URL, you'll type it again. You'll do something, you'll say, oh, it didn't work. I need to re-click load it again. So these timings are often geared around those questions that typically get asked in sequence, okay? First one being, is it happening, right? Do I need to reload this page? Did it fail altogether? So first paint tells the customer that it's happening. So what they then do is they wait for the next question, right? So is it happening? Yes, my page is loading. It hasn't loaded, but it's loading, right? Is it useful is actually the second question. So it then goes from, I'm loading a page, and then they start seeing some content. So things like first contentful paint, right? So this is any content from the DOM, right? So text, images, we say recognizable things, right? This is now saying, am I in the right place from a customer perspective? So I click the link, is it loading? Is this the right link? Is it the thing that I actually wanted? That tends to become the second question. So is it happening? Is it useful? The third one is it usable, right? So, okay, I click the link, it seems to be loading. It's bringing up content that I recognize as being, I'm going to need to interact with this. Can I interact with it? Okay, so an example could be, I click on a news website, click news. Is it happening? Page starts loading and I start recognizing things. I can see, oh yes, it's got news article headlines. Yes, it's useful, I'm in the right place. Is it usable? Are these articles now readable? Can I drill down into things, right? The fourth question from a front end perspective is it delightful? It's a funny question, but it's related to the performance of the site. Now, that's really it, guys. If you want to optimize your front end performance, you want a yes answer to all of those, right? Right? Is it happening? Is it useful? Is it usable? Is it delightful? Right? Because that ultimately then translates back to availability, functionality, performance. It's happening, it works, it's doing what it's supposed to do, it's available, it's functional, and its performance is really good. So I'll probably come back to some of those things later on in this session as we go through some of the some of the charts that we're going to have a look at. But let me just grab a window here so we can look at some stuff, right? Mm-hmm. Okay, this is where we're at today. Browser. Let's have a look over here, guys. So, which one are we going to pull up? So you notice here, even on the, even just right here on the summary page, I'm still getting front-end related information about my applications that are reporting in from their browser telemetry. You can see that, I can see roughly how long the page loads are occurring. And look, there's a huge difference, see? Look, this one here is 3.5 second page load. These ones are 500 milliseconds, right? It's pretty common, right? Different apps, they're going to be quite largely different. This is where I think Apdex comes in really, really handy. Look at our throughput. So page load throughput. So this is, numbers, number of page loads per second. All right. Then, our asynchronous calls. What's going on in the background per minute? How many requests per minute? Percentage of JavaScript errors. So these would be things that would otherwise go pretty much completely unnoticed, right? They'll be invisible to you. Maybe they'll pop up in synthetics if you happen to run synthetic checks that match exactly what it is that your customer was doing to generate these, right? But this is nice because these would be real things that they are actually experiencing. So let's jump into our favorite front-end app. Look, see, it's favorited as well. Let's jump into that one for now and make some sense of some of the things that we see here. All right. Oh, this is interesting. I probably wouldn't have shown this view, but it's defaulted here now, so I can't change it. I'm assuming some of you guys have seen this view before, right? Have you seen this page? This is not actually our standard browser view anymore. It may have been at one point. Well, actually, it definitely was at one point. When I started with New Relic, this was the only browser summary page that you could get. This is the old view. Okay, so we can just spend a short bit of time just talking about it briefly, but you can see here this is our page load, our page load latency. So you can see we're roughly running at about 1.5 seconds for the full page load. There's our Apdex score, and you can see it's broken down from a front end and a back end perspective. And just to refresh your memory on that, we are assessing front end loads on a 1.7 second timing for this app, and we are scoring a 0.8 against a 1.7 second threshold. Here we're scoring a 0.96 against a 370 millisecond threshold. Okay, so comparatively speaking, our app server, our back end, is performing a lot better than our front end if those two numbers are accurately set. Okay, now I can click on that and it takes me straight to the back end. So you can go from one to the other in that view. But I'm going to go back. And yeah, I can see number of page loads. Okay, so I've got my throughput here. A little bit further down, what have we got? We've got session traces. Okay, so these are different to transaction traces. We will talk about them in a little bit. I'm gonna kind of go down these menus and we'll look at some of the points. Here we can see the page views with JavaScript errors. So yes, I can drill down into that and see, okay, well, of the times that people loaded up, the page, show me just the ones that have errors and show me what the errors were. Right, and we've also got data here specifically on Ajax requests and response times. Okay, so that's the traditional view, right? You can get to it quite easily just by turning off that little button there, that feature. But if you go with the new view, which is this one here, and there you go, it's come up now. This, as you probably now noticed, it looks quite a bit different to what the old view was all about. Now, one of the very important reasons for that is these 4 tiles across the top. Okay, so there's some pretty awesome things about what we can see here. Now, here at New Relic, I mean, we try to improve the industry as much as possible. We also try to adhere to all the latest and greatest industry findings, right? And all the new industry standards coming out, right? And here in browser, it's no different, right? Remember how before I was saying that page load is really not where it's at anymore, okay? Now, there's a good reason for that, because the page load is about the actual performance, that, how long the page actually took to load. And what we've come to realize is that's less important than how long it feels like it took to load. All right. So let's put it another way. The customer doesn't care how long the page takes to load. right? I don't know of anybody who's, got the stopwatch out and says go, and then they click the URL and they go, stop, page loaded in this long. No one cares. So thinking about it that way, it makes sense. What do they care about? They care about the perceived performance on the site, not the actual performance. They don't care if it's 10 seconds to load. They just want it to feel like it's loading fast. So here in the industry, we've come up with cool ways of measuring perceived performance, which, in so many ways supersedes actual performance in terms of giving us a good analysis of where we're at with our data. So let's look at some of these things, right? First one here. So, and in case you want to know what these things are, look, there you go. We've even got the name of it there. These are the core web vitals. I'm sure some of you guys have heard of them before. Be cool to get some comments from you guys anyway, if you guys know about this stuff. But yeah, the core web vitals are essentially a de facto industry standard on what timings should we be looking at from a web perspective. All right, so if I'm a web developer, what's important if I'm trying to make sure everything's performing well and my sites are healthy, right? And these are the results that came back. So you want to learn about these. You don't have to go to New Relic for them. You just go to web.dev/vitals, right? It's just web.dev/vitals, and you'll see them all there, right? And it gives you a full breakdown, understanding of each one, okay? I will give you a summary on what these things do. Largest contentful paint, okay? This guy here. This guy effectively takes the place of page load. All right, we used to say how long does the page load? Now we don't care, because when that page load event fires does not necessarily mean that everything's finished. It just means the event fired in the browser. Largest contentful paint is saying when is the largest element on the site being loaded? Because from the customer point of view, the person consuming on the other end, when that large block of content comes up, that is perceived as being a page load, even though the page load event didn't fire. So they go, oh, the page is loaded. Yeah, it's still loading in the background. There's more things to come up. They don't care about that, right? So they want to see things popping up quickly. Largest contentful paint gives us a very accurate representation of that. What else do they want to do? So again, we're going back to, we talked about, is it happening before, but then is it useful? So what answers the is it useful question? Largest contentful paint. How long does my customer have to wait before they understand that where they have landed is useful? What do they want to know next? Is it usable, right? Can I start clicking on this thing, right? Are there free threads available in the browser for it to take my input, or am I still being blocked? Okay, so how do we measure that? We've got this guy here, first input delay, right? What does it mean? Well, it's like it says. When you input something, how long do you have to wait to get a response? What is the delay on the first input received by the site? So it's loaded, it's waiting for some interaction, and we want it to respond very fast so that our site seems like it's performing well. And the last one here, cumulative layout shift, a very difficult one to say quickly or repeatedly. Cumulative layout shift, I have such a hard time, but it's a measure of content moving around on the site. Okay, so if I try and break these down into simpler terms, our largest contentful paint takes over from page load. Okay, it's like, how long does stuff take to appear as though it's loaded? First input delay, how snappy is my site? If I click, does it respond? Or do I click and I have to wait and wait and wait and wait and wait, and then I get a response. So do I have a very responsive site? And then the last one is how annoying is my site? Okay, so layout shift is really annoying. You want this number to be low. Here it's very, very low, right? So yeah, if you've got a high number there, it's because things are moving around all over the place and they don't make any sense at all right? And you try to click a thing, but that thing moved down because a new banner popped up on top and shifted the whole lot down, and it's terrible, right? Takeaways from this. These are timings that are collected by the browsers themselves, right? You guys need to know this. New Relic doesn't collect the information. New Relic ships the information. The browser itself collects it. So Firefox knows about this stuff. Chrome knows about this stuff. Safari knows about this stuff. Other questionable browsers also know about this stuff. Some of the unquestionable ones maybe don't know about this stuff. The older versions don't know about this stuff, right? The point is that they're relatively new timings, right? If you've got a customer that jumps on with a 10-year-old browser, he's not going to collect anything like this, yeah? But anybody with a pretty up-to-date browser, the browser automatically will collect all the timings with regard to the loading that is being requested of the browser. It just depends. Do you want to throw it in the bin, or do you want to ship those timings to New Relic? So we call it a browser agent. We have a little bit of JavaScript that gets loaded when the page loads. That's our browser agent. It's effectively a timing shipper, right? We communicate with the navigation timing APIs in the browser itself. And if I was to put it in plain language, if I was the New Relic browser agent, I'd be saying, hey, browser dude, you see how you just collected all those timings? Do you reckon you could send them to me? Because I want to look at them later. And the browser would be like, doesn't bother me. I've done it anyway. I've already collected all the timings. I was just going to chuck it in the bin. Do you really want them? I say, yeah, please. I even got this NIDB thing over here. If you just ship them there, I'd be so happy. Thanks. So the browser then goes, yeah, all right, no worries. Browser ships it across to NIDB, and you guys get to do deeper analysis on your front end. So that's all that happens. Just redirect timing data that's already being collected, send it straight across. So those are our three main core web vitals. You'll find those and detailed explanations of those if you head to web.dev/vitals. See all the info there. The other one here is user time on the site. We're actually measuring two things here. When does a user navigate away from the window without closing the window? So it's a page hide versus actually closing the browser window altogether, right? So if I, like I hit the X here, like I'm going to be unloading this window, right? It all disappears, right? Versus just, opening up a new window and navigating somewhere else, right? So that gives us a good indication of engagement as well. How, are we capturing our audience? How long are we keeping them for, right? What are they doing here? Now, 75%, you see that across all of these, 75%. What does that mean? And just to throw it over to Ganesh so that you guys don't have to listen to me all afternoon.
The first input yield is 75%?
The first which? Sorry?
Sorry, I think my internet connection is a little choppy today. What was the question that you asked again?
Oh, so what's the 75% referring to on all of these? Because they're all the same.
I think it's the benchmark.
Sort of, yeah. I mean, you'll notice these ones are 50%, right? See that? These are 50, but these are 75.
Oh, those are the percentiles. They are the percentiles. Yeah.
Yeah. So these are now important that you guys understand. So we do have 50th percentile recorded here and all the way down here. See, 50, 50, 50, 50. Now this is a function of this setting, right? We have the median defined, which is our 50th percentile, right? If I go average, it'll show me the mean average. And if I go 95th, obviously it's going to shift everything over to the 95th percentile. But you'll notice that the 75% never change. And actually, guys, this is kind of a good thing, because when you go to Web Dev Vitals, you will see on there that Google has recommended timings. So this goes, I mean, obviously a big part of this is the performance of your site and optimizing the performance of your site. But the byproduct of this is that you're also kind of doing a bit of search engine optimization here too, right? Because by improving the performance on your site and making sure that your timings are within acceptable levels, then you'll rank more highly in results as well, okay? So you can take this seriously. I mean, we've got customers here in Australia that are doing exactly this because of those reasons exactly. There's sites where their ranks have gone down because the performance on the site is poor, and it's not that the site was badly performing, it's that it was badly performing against the highly ranked metrics. So the site was okay, but things like LCP was bad. So they had to be able to change things around and improve these scores to improve their results. Now,
Right.
So for example, first input delay should be below 100 milliseconds to be considered, optimized, which this one is. Cumulative layout shift should be below, I think, 0.1, and then it's good. And then I think LCP should be lower than 2.5 seconds, right? Now, I can just very easily, because I know some of you guys would have done this, but some of you guys probably wouldn't have done this. But if I just show you the site, right, it's very easy, Web Dev Vitals, and I scroll down just a little bit. We're not going to read all this, but look, there are the three. This has nothing to do with New Relic. This is an industry standard, but just by implementing New Relic Browser, you can immediately see whether or not you are in line with industry performance benchmarks, right? I find this is a common question people ask, is like, so, but Dan, what's good? How do I know that like we're tracking okay? Like, is this probably like a good number or a bad number? From a front end, this is it. This is, I mean, the benchmarks are always moving, guys, but currently this is our target, and our target's pointing here. So yeah, there's our numbers, 2.543. Going back to that thing, what is the 75? Why do we have that? And why does it not change? It doesn't change because a good threshold to measure is the 75th, right? For mobile and desktop devices. So those timings that you see here are LCP, FID, and CLS timings on the 75th percentile only. So out of the box, without knowing anything about what the industry is doing, you guys are in line with what what the industry is finding important in terms of performance and things like that. So these numbers will start to change color once they go into the warning and the problematic thresholds, right? So yeah, some really useful things to look at there. I think all you need to do sometimes is show people this for them to understand the significance of actually monitoring the full stack instead of only, well, let's call it 1/4 of their stack or 1/5, right? Because let's face it, guys, if you're doing a 5-second page load and 1 second of that's the back end, and you're monitoring the back end extensively, couldn't it be argued that you're really only monitoring 20% of that overall transaction in terms of time taken? Now, I know what you're thinking. You think, yeah, but we don't control the other 80%. Doesn't matter. You don't control it, but you can still monitor it. You can still look at it, right? It's like when I go out sailing, right? I don't control the ocean, but I sure as hell want to monitor it. I don't control the sky, but I damn well want to look at it. I want to know how fast the wind's going. I want to know what the gusts are doing. I want to know what the swell's like, but I don't control the things. Your front end's
But
the
at least
same.
it gives you, but at least it gives you, all by monitoring all of this, at least something can click and then say that, hey, I can fix something here so that things are going to be better, right? So, for example, just like the other example that you mentioned, you don't control everything at the browser end, but at least that tells you, hey, you know what? You really don't need such big JavaScript. Chop it up into
Hmm.
pieces so that they load quicker. So yeah, monitoring and then getting the stats is always useful. Either you know what are your pain points, or how is it actually performing in production.
Definitely. So for example, just as you just mentioned, right? Let's say you've got an LCP, right? And it's too slow, right? It's 3 seconds, 3.5 seconds, something like that. Why? Perhaps you have a big block of JavaScript that runs just before that, and it has to get through all this code before it then loads the largest contentful, right? As you just suggested, you say, okay, is there a way where we could perhaps run a small bit of JavaScript here, put this thing in, then run this other stuff afterwards, because it will improve perceived performance, right? Again, if we want to stop the user from navigating away too quickly because of performance reasons or perceived functionality or availability reasons, we need to answer those questions in a timely manner, right? Is it happening? Is it useful? Is it usable? Is it delightful? Sometimes it's just a case of reordering the order of what loads when. And it's almost like, well, when that big block of content loads on the page, that essentially resets the customer's mental timer. And they go, oh, something's working. Like, I'll wait another 2 seconds now, you know? But if you ask them to wait 6 seconds with nothing happening, that's a problem. But if they wait 1 second and then something happens, and then they wait another second and something else happens, and it becomes a lot more palatable to wait that little bit of extra time when you can see that things are actually occurring. It's like whenever you're, I don't know, it probably happens in India too, you know, if you ever ring a number and you're on hold, right? And periodically the recording will come back and it will say something annoying, right? Which will be something along the lines of, your call is very important to us. We will get back to you soon, right? That's not there to make you feel happy or anything, right? It's just purely there to make you hang on for longer, because they know that will allow the wait time to increase, right?
It's a filler.
And so, yeah, it's a filler, yeah. But yeah, we need that confirmation that it's okay to keep waiting a little bit, right? And some of these things do that for us. Now scrolling down, we've got we've got our some of our timings here. Okay, first paint, first contentful paint, largest contentful paint. So this is obviously the size of the content now, the biggest thing that loads up versus the first recognizable thing that loads up. To at what point did we receive the page load event? So when did it report complete? And then when did we receive an interaction on the site? So those are some very, very important user-centric timings. And you'll notice that, only one of them really translates to the page load, like the traditional thing that we would look at in terms of important numbers from a front-end perspective. Again, just like with the traditional view, we got throughput, we got JavaScript errors over here. Now, we scroll down even further, we get some other nice numbers here. We can see first interaction broken down by the different devices that are interacting on our site. So how long does it take somebody on a desktop to engage, right? And it takes 2.2 seconds, right? They are engaging more quickly using a tablet or a mobile on this particular site anyway, right? So this is browser, right? So this is not, we're not talking about something like using a mobile app. That's different. This is saying they've opened a browser inside their mobile device, or a browser in the tablet, or a browser on the desktop. So it's all browser data broken down by different device. Now, interactions by agent version. So the user agent, this is important because when you're doing queries, the browser name will be reported as a specific user agent, right? So this is saying Chrome version 72, Chrome version 60, Chrome version 47, right? So just give you some insights as to what's going on. And here is, this is a breakdown by slowest, starting at slowest. What is the least responsive parts of our site? Okay, so the about page seems to be the slowest to respond on this particular site. So yeah, if you're finding maybe important things like the pay now button is very slow to respond, you might be thinking, ooh, well, maybe we should be optimizing that, right? Perhaps the contact us, maybe you want to make that really, really slow so nobody contacts you. I don't know, but my point is that some parts of your site will be very, very important for you to make them very, very responsive, and other parts will be less important to you guys. So here is a timing breakdown of responsiveness by the different areas of your site. And all of this is still just on the summary page. We haven't even gone to anything else that we can see here in our front-end browser data. So Ganesh, is there anything you want to add?
I think the summary page always gives a helicopter view, I would say, on how your overall application is performing. But if you really want to drill down into the details, I think the other views that are available on the browser application page, we should explore them. But in my opinion, Dan, most of the times this page is something that sits on the big television screens on the floor for quite a lot of customers, and then this gives a view on how their application is performing at any given point of time. So yeah, the summary page is really helpful for most of the SRE and then under the front end teams.
Yeah, totally agree. Guys, did you have any questions? We haven't had many questions this session, Ganesh.
Yeah, not many questions. I think we have all front end experts here. Nice.
Look at
Good
that.
to
I
know.
love comments like that. Still processing all the valuable info. Well, thanks for that feedback. We love it. That's excellent. Can I explain the percentiles again? So yeah, look, the percentiles, they're no different really than the percentiles that we were talking about when we were discussing APM, for example. So if let's come over here. So, okay, these are static, right? So I don't feel like we really need to go into these in a lot of detail, but basically it just means that 75%, right, of the browser interactions that we're recording have a largest contentful paint timing of that or faster. To try and put it in easy language, that's really what it means. It means that 75% of your customers hitting your site are experiencing LCP values lower than this, which is good. Okay, the 75th percentile doesn't tell you how much faster it is. If you want to see all that, you could do a histogram, right? But if you want to know, okay, at what point have I captured 75% of my customers, or in this case, 95% of my customers, okay? So look, I got back-end timings here of 1.2 seconds, right? But that's for the 95th percentile. So I'm being pretty strict there. I'm saying I want to know the timing that allows 95% of my requests to complete, right? So how long do I have to wait for 95% of all those requests that have come through to actually complete? Understanding that many of them will complete much, much, much faster than whatever that is, 1.2 seconds. Okay, and it's, I mean, the other way I like to describe it when I'm talking about things like percentiles, just think to yourself, they just did the Olympics recently, right? Imagine if you have to go and sit the marathon, right? You're just going to watch it, yeah? And they put 100 people into the marathon, right? The guy that comes first, he's going to get a very different score in terms of time. He'll get a very different timing to the guy that comes last, right? But you're sitting there in the stadium, and what your real question is how long do I have to wait? I'm looking at my watch. How long do I have to wait until the 95th runner crosses the finish line? That's really what you're doing. When you're saying something like 95th percentile or 75th percentile, you're saying, in a marathon of 100 runners, like I want to go and get a beer. I'm bored of this now, but I have to wait until the 95th runner crosses the finish line. How long do I have to wait, right? And first guy might have finished the run in an hour and 40 minutes. And by the time you get to the 95th, it could be 6 hours. And the interesting thing is to go from the guy that came 95th to the guy that came 99th, he might take 12 hours, right? That's typically the way these distributions work. So from our perspective, from a monitoring point of view, we almost want to say, well, I really do need to go off and get this beer. So I need to determine how important is it that I really wait for everyone to finish the race before I go off and have my beer? And you got to weigh it up, right? I mean, is your cousin running in the race and he's probably going to come last? Okay, then you really need to factor in the 100th percentile, right? Because you said you'd wave at him as he crossed the finish line. But mostly for us, we want to capture a representative sample, right? And you'll find that generally speaking, the distribution will fall where 90%, and it's not always like this, but 90% of all those transactions will all occur within a relatively short period of time. That last 10% is what then takes exponentially longer. And yeah, we allow you to track all that here. The good things about the percentiles is that they are real numbers. They're not modified through averages. So here, this is actually the timing that the 75th percentile took, right? So we have a real number that we're working with here, not just, if we're looking at a mean average, if I get a couple of very, 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 very slow transactions, it's going to artificially skew my mean average to look a lot worse than it really is. But your percentile numbers don't get affected that way. Or put it another way, if I'm sitting there in the stadium watching the marathon, it doesn't matter that the guy that's going to come 98th ultimately doesn't even finish if I'm only waiting for the guy that comes 75th, right? Anybody who comes in after him, it doesn't matter how much longer it takes. My timing has been tracked up to that level. And yeah, it's important because it cuts out all the really anomalous outliers. And this is just a percentile thing in general. It's not specifically to browser. It's why we use percentiles across New Relic for a lot of different things, because it kind of normalizes your results a bit better. So I hope that answers the question. All right, cool. Look, there was a question just coming in just now, and I will touch on it briefly, but I'll rephrase the question as being along the lines of how easy is it to install the mobile agent? And I would argue that I would say it's about as easy as we can make it, right? I'd be interested in your views on that, Ganesh. But look, at the end of the day, you're developing something which you're going to package and you're going to ship it onto a platform that allows it to be downloaded and consumed by millions of people, right? So it's probably going to go to the App Store or the Play Store or something like that. You don't necessarily control once it's there what it does. It just does what it does, right? But your influence is in the obviously building the project, packaging it, and shipping it. As soon as you've shipped it, well, it's out of your hands, right? So how do we install a mobile agent in that case? Well, you can see down here we've got a couple of different options for you. And if we come in here, we say, all right, I'm developing a mobile app. I want this thing to report into my training account. And here is the options that it gives you. And I think they've done pretty well, to be honest. I think it's about as easy as it can be to install it. But really, what we're doing is we're going to name our app. Oh, look, there you go. There's a very, very nice name, X. So we're going to name our app. This is for Apple. Okay, so this is going to be deployed to the App Store. Choose the installation method, right? So depending on my project, right, and then it gives me the relevant instructions, right, depending on which method I'm choosing, right? It gives you a couple of commands. Open up your project, right? So you pick these, right? If we're doing, yeah, look, download the framework SDK. If we're doing it via Xcode, throw the SDK into your actual project itself, right? Package it up, and then yeah, build and run it, and then your customers download your app, and the app is auto-instrumented. They don't even know about the instrumentation. They don't need to know about the instrumentation, right? It's like when you buy a car, there's all this instrumentation like under the hood, right? All the sensors for the engine and the tires and the brakes and everything. It's all there. You just buy the car. You don't have to do any of that. You don't care, and that telemetry is all coming back to you. To be honest, I don't know why anybody would develop an app and not want to see how the thing is performing. Right? That to me makes no sense at all. It's like, I'm just going to build this thing, throw it out in the wild, and be like, I don't know what it's doing. I don't know if people are clicking on the menus that I made, or I don't know how they're using my app. Maybe they're making purchases and that's the only visibility I get because orders are coming in. But I'd want to see the actual utilization within the app itself, not just the requests that come into my backend service from the app. So yeah, Android very similar, obviously different technology, but process is a very similar process. You still have to name it, describe, how you're going to be deploying it, right? Depending on your project, right? So yeah, it just involves embedding the agent code in with your app code and then shipping it off to the store. Okay, good question. Can we assign a severity or probably a priority of some case on in-browser interactions so that you get critical interactions may have a higher score when assessing availability of the whole system? All right. there's a couple of different ways to do that. What do you think, Ganesh?
One thing is we can mark the transaction as a key transaction, and then that would make the but that's for APM. For a browser
Yes.
application, I will need to double check. But for APM, it's very much possible. You can select a transaction, mark it as a key transaction, then you can update the AppDex settings and everything for that separately. And yeah, the AppDex is evaluated based on the new threshold that you assign to it. So that's
Yeah.
APM. But for browser
Mhm.
application, I'll need to double check.
So yeah, I was going to say the same kind of thing. Like there we did talk about this, didn't we? We did talk about key transactions, yeah. So this does allow you to do that, but as you said, it is only for APM. But what you can potentially do is so we've got these which map back to the backend transaction that is performed inside the app. But the other thing that you can do, if you've instrumented the app, you've also instrumented the front end. So when you instrument the front end, and maybe we'll just pull up some tables in a little bit, what we can do is we can say, all right, in this front end table, we can see, for example, the request URI, okay? And so we can break down the front end instrumentation by request URI, for example. In fact, maybe I'll just, I mean, we could just talk about it, or we could maybe just see if we can find the data, right? But let me see what I can see. But yeah, I would think you'd be able to do something like, and I don't really know which, where the data is exactly. So I'm just gonna say, show me the table so I can kind of decide if it's the right place to explain this from. All right, so I did say we were going to be showing you some of this stuff anyway, so now that question's as good as any to get us straight into it. But you notice that over here, this is where we will record all the traditional page loads. So if somebody goes to your site, so hit that URL, load the page, please. That page load event gets recorded here, and you notice that we see the app that the page view was recorded against. We've got latitude and longitude information based on the autonomous system number, okay? So this is the, it's not quite the ISP, but it's similar to your ISP, right? It's the network that you've traversed, right, in order to make that request, right? So anyway, we get location data. With latitude, longitude, we can plot that on maps for you. Okay, we track the amount of time we waited, because from a front end perspective, we know when we sent the request, we know when we got a reply. So we count that as our backend duration, right? Now, here we go. We're going to get some things that might be a little bit useful that can help answer the question. So you notice that we have, for example, the browser transaction name. Okay, so this will perhaps allow me to break down a table based off of this. Okay, but we might revisit that in a second, but that's one thing that we might want to look at, browser transaction names. Again, city info, country info, what device they were using at the time, how long did the document object model take to load, domain, some GUIDs. Okay, that's the actual, that's the name of the page view. So that goes then back to the underlying backend transaction. And yeah, here we've got page URL. That's kind of neat. Maybe we could use that one. So we've got page URL there. Yeah, and then see here, this is why I was saying user agent is important. So the name of the user agent is the browser name. The operating system of the user agent is, yeah, Windows in this case. And then their browser version. And then, yeah, there's some timings here as well. So first contentful paint, first paint, some of that. Interestingly, not all the timings are recorded here in page view. Some of the timings are here, but a lot of them get recorded in other tables that we have. But let's try something else, okay? So let's say, what if we want the 75th percentile, okay? So let's say, I'm not interested in all the records like I can see here. So let me look for the, I hate it when I do that. Select percentile of the duration field, right? Because this is how long the page view takes, and we'll go the 75th, right? So do that from page view, and it'll come back with a number, but it will be one number, okay? And in our case, it's saying the page views. I see this doesn't even really make sense because probably what I want to do is filter it down to an app. So I might say, you know, where my app name is something useful, where my app name equals, yeah, okay, we'll call it Pet Clinic. Cool, run that. Now I've got my 75th percentile on how long my page views take for one of my front-end instrumented apps. Second part to this, can I assign some severity or priority kind of a thing on specific in-browser transactions, right? So that if I have a critical type transaction that occurs on my site, is there a way where I can isolate just that? So I would probably start here and use a simple query like this and say, what if I were to break this up by the page URLs that were requesting those transactions, like they were requesting the page views, all right? And you can see here now we've got the top 10, all right? And so let's do this in a bit of a nicer way. We're going to put it as a table because the billboard data doesn't look good there. And let's see if there's any additional records to pull down. And just for the purpose, you know, for the point of answering the question, you know, maybe, I don't know, maybe the something like, I could say something like the vets, I don't know, the vets transaction, right? You can see it's across a couple of different hosts. There's a way to filter that down, but yeah, I mean, it looks like I can even filter it based on the different hosts the request was directed to. But here I might be saying vets is more important than all my other transactions. So I could say something like this. I'll go where app name equals new Relic Pet Clinic, and I should then be able to just say, well, how about and page URL is like, and we don't want all the front. We're just going to say page URL is like something vets.html. I don't know. I don't know if this worked, but we'll see if it works, right? And then if I'm going to do that, I don't really need the facet, but if I have the facet in there, it'll bring back every page with only, it should bring back every page with only vets. Yeah, which it did, okay? And you can see here, it's broken down into, you know, it looks the same, right? It's just broken into the 3 different hosts. So if it's kind of immaterial to me which host it was, I might then say, well, I don't really need a facet by page URL anymore. But you can see here, I'm tracking specifically my 75th percentile on one part of my overall site, okay? So I just use vets as an example, right? But if that was your checkout button, you know, something like that, if that was your buy now feature and you wanted to track that differently, this is a good way to do, and I hope that made sense, guys. I like to take you from the beginning, like show me the table. I want to see what data's captured, right? I don't need all this. I need just this bit. Let's break it down, right? Now let's look at what my options are. And so I formulate the query, but I'm kind of guided by the data that's there in the first place, or it, otherwise this is not going to make sense. So I was kind of hoping you might have a simple and easier answer to that, Ganesh. That's why I threw it to you in the first place. I'm like, I can answer this, but I'm going to go into it this other way. So anyway, the
No,
point is,
in most of the
yeah,
times, what I do is that yes, the Abdex is the one that plays a key role, but because of all the configuration and the backend setup that we have, we define the Abdex based on everything that's getting reported under one application, right? But for me, I always have my own dashboards. I always have my own queries built to see which of these transactions are the critical ones, and I define my dashboard separately. I make them as customized as possible for the customers that I work with.
yeah, I mean, at the end of the day, I think you really need to customize stuff to make it
Yeah,
really make sense to specifically what you want. So
right.
I think I like to think I don't give you guys necessarily answers. I more give you guys a methodology, right? So I show you how I did what I did so that you guys are then empowered to go back and you can then do this for any transaction, right? Or any front end interaction. All you need to do is, okay, where's the data going? Find the table, aggregate it in some way, break it down into its respective components, and then track those. Because now that I'm at this level right now with what you can see here, right? So let's say this is really critical to me, right? And I really need to know this number. It's a very, very important number to me. Well, you can see I'm pulling out a 75th percentile on a specific transaction within my app. I can alert on this now. It's really easy. In fact, it's easier than it's ever been because we even have a create alert button, which we didn't used to have. Copy and paste was too difficult, so we created a button, right? But yeah, you would have had to copy the query and then go over to alerts and say create a new NURCL alert, and I can see the result of my data here. I mean, if I want to see my data over time, that's easy too. I can just say, well, show me what it looks like, right? Give me the time
Right,
series because yeah, I mean, I'm looking at an instance in time, right? Is this representative of my normal data? And now I can see that, wow, that transaction takes about 1 second. So do you know what? That's a critical part of our site. And if it were to go to, call it 1.2 seconds, and it were to stay above 1.2 seconds for 10 minutes, maybe that's going to be an important thing for me. So it's
right,
in this way, guys, that you can alert on anything. This is what I was saying before. If you can query it, you can alert it. That's it. So it was a great question because it sort of takes us down this other path where we're actually starting to look at our front end data, and we're saying, okay, this is what a page view actually looks like, right? But don't forget the other thing that's really good, and I'm just going to go back to it.
do you think we should break for like
Data.
5-10 minutes?
Oh, definitely. I was just going to come up to this one last thing because I'm not going to do another query at the moment. But yeah, I was just going to say, don't forget, guys, we've got the data dictionary here, and we can say, for example, we want, oh yeah, click on that thing, right? So we can go by data type, right? Which is actually, drilling down into our tables. We can go by data source, right? So from our point of view, in fact, this would be the best one to look at the moment. We're saying, okay, we're talking about browser and the browser agent. What are the tables that have data being reported from browser agent? And when, right? So I've told you about this guy already, Ajax request, right? It's going to happen as a part of the browser interaction event, okay? Now, you want to know about that? That's fine, because it's here as well. Okay. These are all the individual fields. And there's browser interaction, right? And it happens when a user interacts with the web page itself, right? So if you're wanting to track specific things, like if they click on the Pay Now button, right? That data would more likely be better served in browser interaction, because they have to do something. So that data will be captured there and not in page view like I just showed you. But the methodology applied would be identical. I just said, here are the URLs, filter them down. You'd say, here are the interactions, filter them down, right? So I'm going to leave you guys with this here. That's all the browser agent tables. I think it's a very, very important thing for you guys to have a bit of a browse, I guess. But look, I'm getting 2:38 p.m. I'm going to call it 2:40. Let's come back 10 minutes after that. So how about 2:50? Okay, sounds good. 2:50, we'll come back and we'll maybe Ganesh can show us a couple of his favorite queries. Yeah, maybe we can do some of that. And then I got a little bit of just a small exercises to do today as well. All right, so speak to you guys very shortly. Hey guys, we back. We have more things to do. All right, so where we left off, we were talking about gathering data from page view, which is essentially what gets captured when a page load occurs. I feel like I should also point out, in fact, let me just go back. I'm going to share this out again. So you may have noticed, or maybe you didn't, when we looked at the table itself, right? And this is why I really love just looking at the tables. You can see everything that's captured, okay? And we went through this, right? So we looked at the app name and, you know, latitude, longitude. So a couple of things. Sometimes the same data will be captured in more than one table, okay? That's not a problem. It does happen. But sometimes the data that we think is captured is maybe not in the table that we're looking for. So why I'm pointing this out is because you guys heard us talking a little bit earlier about some of the very important timings, right? And we weren't talking about first contentful paint or first paint. Those are the only timings that I can see here in the, well, I mean, there's a couple others, web app duration, there's duration itself, queue duration. So there are a couple of others, but the ones that we talked about earlier are not actually here in this particular table. That stuff is recorded under this guy, page view timing. Okay, so for those of you that actually look through the data dictionary, this is all in the data dictionary. Okay, so I just recommend go there, go to browser. To me, that's the easiest way. I like to think of it from the agent point of view, right? Where is the source of my data collection? Okay, so if I'm gathering data from here, now I know it comes from browser. Where is it going to go in terms of tables? And if you had a look, there's about a half a dozen, right? There's Ajax, there's browser interaction, there's page view timing. There's 2 or 3 others that I'm forgetting. I think there's about five or six, something like that. Anyway, if I look at this one, I'm looking at a different table now.
There's page action, page view, and a bunch of them.
Page action, yeah, I completely forgot about that one. Yeah. Notice the case sensitivity on this as well, right? There's 3 caps in here. Okay, if you type it all lowercase, you'll get no results. Right now, so again, you're going to get same kind of things in terms of latitude, longitude, app name, right? But I tend to think of this as it's almost a little bit like a table extension, right? We've got a couple of extra fields here, and that's because for the newer browser versions, they are capturing additional info that the older browser versions don't capture. So whereas the older ones can just report directly into page view, the newer ones can also send their data, which has new timings, into the page view timing table, which includes things like page hide, which you won't find anywhere else, right? How long until the back button was clicked kind of thing. So we've navigated away. And you can see here, these are our timing names, right? So these are totally different fields that we couldn't see just in the standard page view table. But some info is very familiar, like user agent name, user agent operating system. Now here you go, we've got first contentful paint. Of course, out of the transactions that I'm looking at, actually maybe let's look at a different app. Okay, so just looking for timings. Yeah, here we go. See things here like first input delay, first interaction, So yeah, first interaction occurred at 1.2 seconds and it took 294 milliseconds to respond to that interaction that occurred. What was the interaction? It was the pointer down interaction type. Okay, so it's pretty cool. There's some, really some detailed info that you can grab here. It tells you about what the interactions are. Yeah, you notice that sometimes our real, you're going to get this kind of thing happening as well, right? You'll get some kind of real interactions in your browser tables that come from a synthetic check, right? From your site's perspective, your site doesn't know or really even care where the request came from. It just services the request, right? But yeah, look, we've got cumulative layout shift, right? Largest contentful paint. Okay, so this is where that data is being captured. Now, yeah, not every transaction will record every single timing. Okay, some of this will be governed by things like the browser version that the customer might be using. It'll definitely have an impact, like the browser agent version that you guys are using will definitely have an impact, but it's also going to be things like their actual browser that they're using may not be collecting the timings. So that's why I was saying before, we use the navigation APIs in the browser itself. The browser has to first collect the timings before we can then have a New Relic agent that says, can I have those timings and can you send them to me? So if the browser agent version is too low, it won't collect them in the first place. Even if they're using an up-to-date browser, if your agent is too low, the agent won't know to ask for those timings, even if they're being collected. So they still won't be sent. So sometimes you'll see this kind of thing. I would assume that over a period of time, as all browsers sort of update and update and update, and more of them collect more timings, you'll see fewer and fewer gaps over a period of time. But yeah, I just wanted to point out that this front end data goes to all different places. So if you were looking for those timings we were talking about earlier, they're all here in page view timing. Ganesh, you want to do a demo?
On the NRQL query, so to identify a value, or which one do you want me to? Should we just jump into one of the browser apps and then take through?
Well, there's kind of two things that we need to do with these guys. I would like to we need to show them the other menus, right? And we need to describe them a little bit. That won't take very long, but we can do that, and also show some of those queries that you wanted to talk about as well. So I don't know if you want to maybe go through some of the menus first and then maybe show some queries after, but we don't have to go through things like the distributed tracing and the service map and the dependencies, because we kind of covered that same stuff in APM anyway.
APM,
right?
yeah.
Yeah, but maybe things that are a little bit more unique to unique to browser, like the session trace waterfalls are different. And yeah, the page view is very similar to transaction, so you don't have to spend a lot of time there, but it's nice to show the interface anyway. Yeah.
Sure. I hope my screen is visible.
It is.
One thing that I really like with the new view of be it browser or be it APM or anything, Dan, is that if I really don't want all of this detail and I just want to put them on one dashboard, and I just need only, let's say, just how was the first interaction on my user agent, I really don't have to go about finding which data item I need to find, which dictionary and all of that. I just have to click on this 3-dot view query, copy this query that I get, put it on a new dashboard. That's fantastic. I really like that one, right? So that's the reason when you ask me which is, if I want to take them through a few of my favorite queries, I really didn't have to go ahead and then build them. I can find them on this dashboard right here, and I can just use this one everywhere, right? So yeah, so this page, summary page, we already saw the golden signals, the web vitals that we were seeing here, and then we also looked at the drill down of front end versus back end, and furthermore the throughput and also the interactions by device type. Right? This is very interesting because for most of my mobile first customers, I see mobile as like 95% and probably 5% on tablet and then on desktop and then tablet, right? 90 plus percentage I usually see it on desktop. And when my mobile app is down, when their mobile app is down, I would see the interactions falling very badly on mobile. Um, yeah, so this summary page always gives you a helicopter view, 10,000 feet overview on how your app is performing. The next thing, just like in APM, how we saw in APM, we saw backend performance and then we went into individual transactions. So similarly, if we look at browser, the similar one here is page views, right? So if I go to page views, this one is going to give me list out the all the pages that it captured based on the browser interaction that the user did. When I say browser interaction, I'm talking about a user trying to load a page, or if the user is trying to, you know, refresh a page or load a page or do some interaction, then submit something, right? So what is happening on that browser interaction here? So this is a demo website, as you can see. And if I click on any one of these transactions, let's say I clicked on the services.jsp page, just like how you're seeing on APM, you will also see how much is the backend time, front-end time, and also the window onload time, again, split across the basic web vitals. And going down would further give me, just like how we are seeing on APM, where you can see the complete transaction trace. Here you are seeing the session traces, because transaction trace is more relevant for backend, whereas for front-end, it's the session trace is more relevant, right? So all I have to do is just click on one of these, and then this would actually take me, if you see, the view has changed from page views to session traces here, right? In the session trace is where I can see the complete waterfall model of how the page was loaded, including the individual resources. How long did each of these resources take? So for example, here, as I can see, I see a main.css file loading first. That's when, if you look at the events here, the first one is the navigation started, fetch start, basically every activity that's happening on the front end, right? Domain lookup end, the connection started, and then the request has started, and then the response already started here, right? You see, the request was done, and then the response. This is basically the TTFB. If you are into performance engineering, you want to understand what is TTFB, the time to first buffer, time to first byte. That's when the response started coming back to your client, right? Then there's a DOM loading. You started having all of your response started to come back to your browser, and then there is an event that got triggered where, hey, the response started coming in. Let's start painting the content, right? And that's where you have main.css, other CSS files. And if you see, there are a bunch of JS files that are getting loaded, and there is one huge JPEG file here. If you can see, if you want to see the timings of these individual components of this page or resource of this page, all you have to do is go right on top of it, and it tells you what type of resource is that. It's an asset because it's a JS file. And then you have how long did it take, when did it start, what time did it end, and what's the overall duration, and the complete location of the file. You see, there is JS. So from the root directory of the HTML page, there's a JS/simplecart.js file, right? And as it is pretty clearly visible here, while main.css and others are loading in like within few milliseconds, there is this spaghetti services.jpg file which took about 1 second, 949 milliseconds, right? And then scrolling down, I still have so the DOM content load has finished, and now here you have the DOM interactive. That's when the customer started interacting with the page and what happened during then. So DOM is completed here, and then the load event started, and it's trying to load everything else. So there are different types of events that the front-end developer would write as part of the page design, and these are all such events that are getting loaded, right? So this one gives the front-end developer a very clear picture on what is happening when he's trying to load the page, what resource is loading quicker, which one is taking longer, and how long is it taking for each of those resources to be loaded, right? So for example, I can see this one. If I click on this, this one is going to send this, basically the view gets entered to this resource and it gives me all of these details here. So you can just go to the front-end developer and then say, hey, you just added a spaghetti services.jpg file, which is contributing to say 90% of my overall page performance. So if you see, the overall duration is 1.3 seconds, out of which 950 milliseconds is because of this JPEG file. Do you really want this one, or can we just get rid of this? Maybe instead of spaghetti services, just add, a lightweight, less fat services.jpg file here, right? And that is about session traces, the way how you can jump between page views to session traces. Apologies for the disturbance that's coming from the back end. The neighbor just decided to do some wooden work right when I'm talking out of these 3 hours. Yeah, that's about page views. So yeah, so we went to page views. We saw we saw the first level metrics, and then we tried to drill down into individual traces, and that's when we saw all of these traces here, right? Session traces, page views, um, Ajax requests, right? This is another one which is very important. So while you know that from a page side, browser interaction is the one that's giving you the whole page data. The Ajax request page is the one that tells you any Ajax calls that are happening on a page, not with the full page load, but all the Ajax calls that are happening. This is categorized, this specific category is only for such calls. For example, let's say you are on a checkout page, you enter a discount coupon that you have, and then say apply. The whole page never loads. It just makes one call and then gets you back the response, which is something similar to this, right? As you can see, there are events, and then yeah, exactly. I think there's a very good example here. Is the coupon valid or not, right? If I click on this one is going to give me response time of all the web vitals of that specific request. And I have not just this, I also have option to look at this one by page view. So basically, on which page is this Ajax call made the most? I can look at this view as well, where you're seeing that 100% of these calls are actually happening only from the shopping cart, right? If I go to Ajax performance, there is also a session trace. Again, it's going to take us back to which session trace that did this happen, did this trace happen, and we should be able to see it highlights the call there. You can see this, right? So this call actually came back with a 500 response, and that's the reason it's highlighted as an error here, right? So all you had to do was few clicks from page views or Ajax calls, and then it would bring you to the proper waterfall model, and then gives you details on, hey, you know what, I am able to see this one in this specific page. After this event loaded, this is when this call started, and that's when I'm seeing an error, right? If I have to click on view full details, it would bring me back to this page and then show me the overall performance of that particular call here, right? Then jumping to the JS errors. This is very interesting. I really like this one because while most of the developers understand, the front-end developers understand what a specific JS error means, few SRE teams do not understand this. All they say is, hey, the page is loading fine. It's just that this specific functionality not working. What went wrong? I don't know. All I have to do, I'll have to go ahead into developer tools, try to reproduce this error, and then get the error message so then I can share it with the developers, which is not something that I can do when my customer is sitting probably somewhere in New South Wales and I'm sitting in India and my developer is sitting in the US, right? So what do I do? While doing this one, this is where what the browser agent does is it's going to collect the details of every JS error that happened at a browser level and brings it back to the New Relic One platform. And that's where you're seeing all these categories here. And if I click on a JS error, there are all these errors split up based on the total number of errors. So now in last right now, as you can see, I filtered for the last 30 minutes. And in last 30 minutes, I have around 346 instances of these errors. And out of these, again, when I just go and then tell the developer that, hey, I have this error, he would ask for more information. He would say, get me more details. If you tell me this is the error message, I don't know which customer, where, on which device. Give me more details. And that is when this is going to help, right? So now, if you can see, it tells me that there were 346 instances of this error, out of which 300 of them were observed on a Chrome browser, and most of them are on desktop, right? And then I can get more details saying that how many of them actually came now, how many of them came last week, and which URL is the one that's triggering this error. And I have few examples here that I can show to my developer and then say, hey, dude, go ahead, fix these issues, right? That's about JS errors. I'm just going to go back once again to show some more details on the JS errors here. Just going to click on this. And here, as you can see, this one is showing me like, the top 20 results here. I don't have 20 different types of errors. I have only few of them. And for all of these errors, this shows me, the number of instances, and it also shows me which browser caused this. And another one that I really like here is the error profiles. This is a beautiful view, which also gives me, I really don't have to go into a specific error message and then get more details. I can get it from here, right? I can go ahead and then see 72% of these JS errors have this transaction. They're coming from phone.jsp, right? And 58% of this actually came on the page with the URL, which is this. So this is my backend transaction, this is my web transaction, and this is my front-end URL as well, right? And how many accounts how many sub accounts are reporting this error? There are like 4 accounts that are, I can just click on this and then get more details here, right? If I really want to go into this and then see like all of these calls, like 58% are coming from this, but rest of them are also coming from these page URLs here, right? A lot of detail that's available. It's just for you to understand. And then, the error profile section that you're seeing here is made so easy to understand. It's literally the language that you speak to your developer, right? You can take these statements and then use these statements to your developer, and then he would understand what you're talking about. So yeah, that is about the JS errors. And the browser section here is very interesting because as for me, this one is a fancy view that we can use to put it on the dashboards or do some more analysis on. This is more of a business insights for me, wherein I can go ahead and then say, hey, you know what? Out of 100 of our customers, 90 of them actually use Chrome. So can we improve our performance a little bit better there, right? Or if we find that there are customers that are using Firefox and we know the performance is bad there, can we do it more so that we can drive more Firefox customers to this? And you have options to, throughput is more on this. If I say average page load time, the maximum time it takes is on mobile Safari, right? People who are on iPhone using Safari browser are the ones that are experiencing the maximum delay, maximum latency. And these are, so it basically makes it easier to identify the pain points and then share these details with the developer to get them prioritized. And the last one is filterable geography. This is the one that I really like because this one gives a beautiful map view here, and all the executives really like map views to be on their big dashboards. So I always try to keep one map view on one of the big screens on the floor. It makes it look really fancy and also gives you details on which location things are performing better in which location. So now if you see this one here, this is based on average page load time. I have some fantastic performance in Canada and in the US, quite a bit of poor performance in South Africa, and kind of okay performance in India, I would say. And yeah, even Germany is kind of okay. But then there is this like small spot. I don't know what this is. Oh, it says Frankfurt. Frankfurt has just this one has some bad performance there. Okay, anyways. So yeah, so here is the scale. It's again, the scale is purely based on the response time range that is observed from of your overall browser interactions, and based on that this geographical representation is presented by Relic by default. We don't have to build anything for this. And then you have a lot. Every single attribute that you can filter out is available here. If you really want to see just for if you really want to see only for your Chrome, you can actually do that as well. I will say just show me the metrics only for Chrome, and then there is all possible filters are applied here, and this is only for Chrome here that you're seeing, right? And if I have to say back to the grouping list, and if I have to say show me how my services page is performing across, just click on this one, and then I have a different view here. It says services.jsp was never used in India. I don't know, no one in India used it, right? But then a lot of people use it in Brazil, and then they have a very bad performance, like 4 seconds of it, right? So you really do not need to set up your own dashboard for this one. The inbuilt and the curated view that's already given here is fantastic enough to drill down as much details as possible. But if you want to build a fancy dashboard, yes, you can take this data and then put it on a dashboard as well. Yeah, I believe I've covered all the menus here, Dan. So back to you. Did I forget anything?
Yeah, thanks for that, Ganesh. Other things, well, there's probably just one or two other little things that I'd maybe point out. As you guys probably imagine, so that chart is interactive, right? So you can click on one of the regions and it will actually zoom in, so you get a more detailed view, right? And you'll notice that it now then applies that country filter and the region filter. So I mean, you could just do it by search keys and attributes and do it there, but it's kind of nice that the map itself is interactive, right? So yeah, just filtering by country and region code, again, very easy. To zoom out, a little bit counterintuitive. You can't zoom out, you have to remove the filter. So yeah, as Ganesh is showing you there. Now, so you'll notice that we can group by any number of different meaningful things. Common ones are things like, show me the different browsers that people are using from around the world, and let's see the page view timings based on those things. So yeah, you might do user agent name. You might use things like page URL, right? Like what pages are being hit the most from different regions, that kind of stuff. Then yeah, you see, so then it gives you a breakdown of page URL from slowest to fastest, and then it gives you the overall map view of everything. The other thing that I find people doing here on this particular chart on the filterable geography, so at the moment we're looking at the average page load time, right? Which is just it's a nice baseline metric, but as you guys know, it's not everything, but it does tell you a speed kind of a measurement. But if you go to the drop down on that, on average page load time, there's a couple of other things that are really, really nice to look at. So one would be, for example, session count. So if you go to session count, this then goes from, instead of giving you timings, it tells you number of users, right? I mean, it's sessions, but it pretty closely translates to number of users interacting with your site and where they're coming from. So again, that can be really, really useful info. And if you want the throughput info, so not necessarily users, but number of times people interact with your site, you would go with the count option. So count is roughly equivalent to throughput. Session count is then your users, and then page load is your latency, your average latency of the site load. Right. So yeah, there's I mean, there are other timings in there as well, as you can see, but I find that they don't really get utilized that much. But those are the ones that definitely get the most activity. Probably, I mean, the only other thing that I'd maybe point out, because I think you covered everything pretty well. If you want to jump into JS errors, there is one other cool feature that we haven't really talked about, but occasionally, and it sort of goes once it gets passed to the web developer, and they're probably going to have a question, which might be something along the lines of, I wonder what happened leading up to this error. What did they do just beforehand, right? And actually, the cool thing is we can show that as well, right? And that was just one thing that we missed. But if you're a web developer, I mean, we showed the overview, but you can now drill into a specific error, and you'll notice there that there's an event log, right? And you can see here there's it's minimized at the moment, but you see that right there, event log, it says 3 frames. It'll just show the few steps that occurred right before that happened, right? So and then just above where you are, Ganesh, you're looking at the stack trace, but you see the event log just above there. Yeah, see? So you can see, well, we loaded this page, and then that's what caused the timer to start. So then we later got an error, but we can actually see, well, this is what was invoked before that, right? And then the timer commenced, and for whatever reason, the timer timed out, okay? If you're really so inclined, you can even send in the source map for your JS, and we can then unminify it down the bottom in the stack trace there. So you notice if you scroll down a little bit, it's giving you the option there saying, I can't tell you, like, the system is saying, I can tell you there's a problem at line 238, column 13, right? That's where your problem is, but I can't show it to you here. But if you were to provide me with the source map, then I would actually be able to show it to you in line with the actual error, that's pretty sweet as well. It's like, here's your error, here's your lines of code that are producing that error, just to try and make your life easy, right? So yeah, I think that's a nice, cool feature as well. All right. Okay, I think that was pretty cool. That was a pretty solid demo, Ganesh. I liked it. Thank you very much. Just looking at questions that have come through, there's been one question, a bit unrelated, talking about muting rules. And you want to mute alerts during deployments, right? Yeah, I mean, that makes sense. I get that totally. Do you want to just pull up the muting rules quickly, Ganesh, while you've got the sharing going on? I mean, I guess it's not really related to front end, but then again, it's related to everything because it's alerts, and you can alert on the front end, so it's not unrelated. Yeah, one of the muting rules are a bit of a funny one. They're actually at first when you see them, you think, no, that's a bit, like, how do they work? It's weird. But they're actually very clever in the way that that they get implemented, right? So if you were to add a rule, right? I mean, in a traditional alerting type mechanism, you'd kind of think that the ability to mute an alert ultimately lies with the alert itself that you're wanting to mute. That's kind of, I would say, the intuitive approach to what gets done. We don't do that in New Relic. And at first I was thinking, but why not? But what we do is more powerful than that, right? And it makes a lot more sense. So you notice you do the standard stuff, you name and describe your rule. Yeah, big deal. Where is the rule going to live? In what account? Okay, cool. The next thing we do is we have this thing called a violation filter, right? Now, what's cool about this is that you can filter against certain things, like, for example, the target name, right, or the target ID. So you might have an entity, right? Let's say, I put it in real simple terms. I've got an application, right? I need to do a deployment on the application, and I do that every Tuesday night at 9 p.m., for example, right? But there's also 35 alert rules in place. I don't want to have to go through every single alert policy and put a rule in saying, oh, wait, that app, don't do that app, right? So rather than doing it based on the alert itself, you can do it based on other things that might make sense. Like I've defined a condition, and I don't like, if you've got a condition for things like AppDex, and then you've got like a performance cycle, maybe you'll say disable that condition when you're doing some performance level maintenance or something like that. Disable alerts when you're interacting with this target. So irrespective of what policy the alert lives in, if the policy invokes that target, don't fire an alert. So you see, it adds a lot of value there, because you don't have to then go and say, well, geez, I need to do maintenance on my app, but I know my app's got 7 or 8 alerts on it for all different things, right? I got to go in and manually disable each one. No, you don't. You just say that app this time. And I'm just talking about one attribute, right, which is the target name, but you can use the ID of the target, you can use the policy. So you can just disable a whole alert policy if you want to. And you might choose to do that if your app is only subject to alerts because of one policy. That's a nice, simple, easy way to manage it, right? But yeah, you can mute conditions, policies, or mute things that will interact with specific targets or specific queries, right? So yeah, there's more functionality than you at first see when you play around with muting rules. Right. But yeah, taking that back to a front end context, yeah, you can have a NERCL alerts, for example, that might be defined against certain front end targets, or you have performance things that you're going to be doing that will affect your front end, right? And if that's going to be the case, then you can disable your front end alerting by specifying the specific target, right? Doing it there. And then, yeah, below that, I mean, that's the only part that might need a little bit of explanation, I think, is the building the violation filter, right? And you can apply multiple different criteria there. And then after that, it's just a case of you defining your schedule. That's it. Simple.
Yeah, and this muting window is like is super easy to understand, because I like how similar it is to your Google Calendar, where you schedule your meetings in repetitive meetings or recursive meetings. You just give the start date, end date, and then tell how many times it should repeat and how frequently it should repeat. So yeah, it is pretty self-explanatory here.
All right. Did you have a couple of queries that you wanted to show particularly, or was there nothing that you specifically wanted to go into when we were talking about it before?
I wanted to talk about the. I thought I'll show you the queries that I was using for specific device type and also the browser type. But like I said, they are very much available on the homepage itself. So all you have to do is just probably what I can do is I can just open the query and then explain it a little bit.
Yeah, let's do that.
Yeah. So I'm just going into this one, and if I want to see it based on device, I can just say view query. And this query, if you look at this one, again, because it was already given as 75th percentile, and here we are trying to get the response time of the first interaction. So we are looking at the first interaction response time, first interaction time, and we're taking a 75th percentile of it from page view timing type. That's basically the table that Dan explained a bit ago, which has all the web vitals, including first interaction, cumulative layout shift, largest contentful paint, and basically all the metrics that we spoke about, all the vitals that we spoke about. And app ID, this is very specific to this application because this query is auto-generated. The app ID is not necessarily the name, the readable format, but it's actually the ID that that is assigned to this application. And if the device type is unknown, basically the people who are using the age-old devices, which are probably running on like Android KitKat or something, Android 4, probably that's when the agent is not able to collect the data, it just says device type is unknown, which is something that we really should not be worrying about, because you really don't want to spend your developer efforts fixing your front-end performance for Android KitKat or iPhone 3, right? So whichever is available, you're going to take the device types and then get this. And first interaction is less than 300. The reason why it is mentioned as first interaction is less than 300 is the overall duration. If it is less than 300, that's like 300 seconds is what it is, right? And we really don't want that number here. And you're just applying a facet of device type. So you're trying to get whichever is give me the list of all the devices that the customers are using, and limit to 10. And limit to 10 is like, give me the top 10 devices, right? Not everything. And since last 1800 seconds ago, and this 1800 seconds ago comes from the timing that you're selecting on your summary page, as simple as that, right? So the one that you're selecting here. This is about device type, and the other one is about user agent. I would really like to play around with this query a little bit. I'm opening it in Query Builder, and I have the browser here, and then I want to see my 95th percentile, and then I would say I'm not worried about this one. I'll say Faceit, give me the user agent name and the version of this one, and then show me since 1 day ago, right? So since 1 day ago, my top worst performing 90th percentile first interaction pages are accessed on a Chrome version 60, Chrome browser version 60, right? I can add a device type as well here. I can say facet of this one, and then say comma get me the device type. Do I have the device type there? There you go. I have the device type here, and then I'd say run this, right? So Chrome browser running on version 60 on a desktop is the worst performing combination in the last 1 day. I can play around with this, right? I can see Chrome version running on 30 on a tablet is the worst performing one here, right? And just to make sure that I have enough number of transactions, if I really have to, this could probably be just like, this person using a very old version of Chrome. So if you know what version it is that you want to really target about, you can just have, so for example, we always have had this monitor where, when there's a new version of Chrome that's coming up, we always had an alert specially just for that version to make sure that whichever customer is updating their browser, I hope they're not breaking anything on our side, right? If our website is not breaking anything on the new version of Chrome. So that is something that our front-end developers have automated, and then they would set up an alert or add that query on the dashboard and then say, hey, for this version of Chrome, keep a tab, tell if something is going wrong, give me the number of JS errors and the Ajax errors and the performance just for this one. So that's the optimized level of maturity, I would say, wherein all these queries are integrated with the Terraform. And whenever there's a new version of Chrome, they would just update the Terraform with the new version of Chrome numbers there, and that would give this detail, right? So yeah, so these are like couple of queries, how you play around with the device types, any field that is available as per the dictionary that you're seeing here. More than we explaining that, I would suggest play around, try to write your own queries, and then see how things are looking. And if you have any questions, try to look at the data dictionary for your reference purpose. And yeah, that should give you enough detail. Anything else, Dan, that I should add?
No, that's pretty cool. Yeah, that was good. It just questions come through. How do you know? How do we know it's the browser? Or where it could just be a slow PC, from the customer's perspective. But I guess that's where the aggregated results come in really, really handy, right? So if it happens to be that it's just happening once or twice, it could well be the PC. We actually we can't differentiate between the two. But if we're seeing hundreds of instances of a browser, a version, then we can guess it's probably this browser. And maybe they're also on a slow PC. But yeah, sometimes it's just that we have to aggregate it out and extrapolate that, well, we seem to be seeing this thing a lot, right, compared to that thing. So yeah. Probably last thing I'll ask you before we finish up today. So I do want to give you guys just a little, I'm going to give you guys a couple of queries to run for yourselves, just so you can go in there and do a couple of things. But before I do that, would you like to just show a couple of mobile things while you're there, Ganesh? So you guys will see when he goes over to mobile, a lot of it is quite similar anyway. I mean, there are obviously differences, but we won't have to go through every single thing, right? And the one of the challenges that we have is we don't actually have a lot of mobile data coming in on the accounts that we have access to. So there's not a huge amount of things to look at, but you can see we're just trying to increase the sample size here to get a bit more data appearing. Look at that, no crashes at all. But you see front and center, we've got crashes, right? That's right away a bit of a different thing. But yeah, if you want to just run through a couple of, I suppose, key things from a mobile perspective, Ganesh, that'd be cool.
Sure. Yeah. So from mobile monitoring, again, what New Relic as an agent, the agent that is running along with your mobile app. I think someone also asked a question on how would you monitor, how different is the instrumentation compared to browser to mobile, right? So while on a browser side, it's just a code snippet that you add in the on your HTML pages, and that would send all the information like a JS that runs along with your browser. But for mobile, it is little different. Like Dan just showed you some time back, that he showed you the guided install where you select what operating system and what framework, and based on that, it would give you the list of steps that you need to follow. For example, when I say the list of steps, I'm talking about um, the steps where you add a library to your overall package, you rebuild the app, and then deploy it, and that would send you all of these details, right? So similarly, once that is done, the kind of details that you get here is one, all the HTTP response times from a mobile app. Obviously, there are a bunch of calls that go over HTTP and then back, and then back to the mobile app. So you can see the response times here. And if there are any specific errors that are happening, it would show, are these the network failures or are these the HTTP errors? So it could possibly be made an HTTP call and then it got back a 500 response, right? Or a 404 response. So those are captured here separately. And additionally, if there is a network failure, let's say unable to connect, right? So those are the network failures that are captured separately, the two different types of errors. And these are the crashes. The mobile app crashes are always split or distributed across the version types, because that's the most interesting thing for any mobile app developer. When they integrate it, they would really like to know if a customer is saying that, hey, my mobile app just crashed. First question is, what version are you using? Did you update the version, right? Or do you have the latest version on your mobile, right? And then the app launches, the number of times your application is launched, again at different versions, because if you have launched a new version of your application, you really want to see that grow, rather than the older one having more number of launches, right? So this is about the number of launches that are happening. And I am just going to jump to crash analysis here, because most of the other ones are very similar to what you must have already seen, right? So crash analysis would give you based on what are the types of crashes that happen and what is the error message that is captured by the library. I just have to click on this one and click on this location. And this one would give me details on how many crashes happened during this in last 7 days and how many times did it happen. You can see the complete count here, right? And again, device type. I can split it based on device type and OS version. So right now, the OS version, because this is Android app that we're seeing, they're on Android 9. And the device model is Moto G7 Play, right? The additional information I'm also going to get here is that just like how you saw on browser, there's a stack trace and then there is an event trail on what led to this error. This one is more detailed on the stack trace, but if I go to event trail here, event trail tells me what the customer tried to do. The customer launched the application and then went to telco home, and from there clicked on home again, phone list fragment, basically clicked on phones list. And that is when there was a call that was made to the backend and the DNS lookup failed there, right? And then the application crashed because of that. So this is basically the list of the few interactions that the customer did. So if you see the icons here represent what exactly is this. This is a call that is made to the backend, and there's an error here. There's a request error, and these are actually the interactions by the customer. And here is the app launch, right? I really have to go into the details. I click on this one, and this one has further more details saying, what happened to the network, what is the response body that was received when this call was made, what type of error is it, how long did it take, what type of call, basically request method, and what URL was or what URL was called, right? The same level of detail would also be available for every interaction. If you can see here, what happened to this one, right? So this is basically the interaction never completed because there was a crash that was observed, right? But for this one, it tells you what is the interaction duration, especially while clicking on home fragment or telco home for that matter, right? You get all of these details here. So this is about how you see a crash, look at the detail, and also look at the trail on what actually led to this crash. And further more details, again, just like how you're able to split based on or look at the view based on the type of browser there on the browser based on user agent on the browser module. Here you can look at on Android how many because there's an Android application, you're seeing it based on the versions. You can see for 10 how many launches happened, for 11 how many, and for 9 how many of it, right? And if there are any sub versions available, it's going to list them out just below this. Right now there's only one version available here in our test environment. Again, based on HTTP response, which one is having the worst HTTP response, how many app launches are happening, again based on device type and OS type, and then here it's based on device here, right? So you can see the maximum number of launches are actually happening from LMQ70, Q720 device, if you're on Samsung phone or if you're on a Pixel device. Tablet, Samsung phone tablet here, you still have the option to drill down based on error rate, duration, and how many number of requests are happening per minute. Right. All right. With that, I think this is at a very high level how you can how once you do the instrumentation, what kind of detail that you get for mobile, especially crash analysis is something that's very important. And additionally, you can look at an overall, forget about crash, how your overall application is performing. You can still go ahead and then look at go to interactions. This is very similar to the page views in browser, transactions in APM. Here it is interactions, and then you can see how each one of them are performing based on count and also based on average time for each one of this, right? Yeah, Dan, you think, is there anything else that we should cover here?
From a, well, just actually looking at questions coming through here, there's, I don't know the answer to this one. Do you, I mean, I have an idea, but I'm not sure of the answer. Do you know if the app tracking prompt gets raised on their iPhone? if New Relic is instrumented in the mobile app for iOS.
I don't think it would, because this is not an external tracking that is happening, but it's part of the app build. So it would not ask that prompt.
Yeah, I mean that would be my understanding of it, because it's part of the app code
Yeah,
itself. It's all within.
correct.
It will to the OS. It will look like the app is just doing what the app does.
If you're installing the app, you say, I've read and agree to all the conditions. Yeah, it's part of that.
Yeah. And then next question came through just with regard to doing things like A/B testing. And so for using these views, I mean, you can see that we do have, there is a version, there's a version trends page, which will assist with that a little bit. So you can see that, I mean, there's no data there because we don't have any iOS data, but if you flick over to Android, there is a little bit there. And it does show, okay, this is, you know, this is what's going on in terms of number of users, upgrades, new installs, right? What's the crash rate? And this is from launch day, this is launch day, launch week, launch month, and show me all the data that we have. And this is then broken down per version as well. So if you want to see just this, you know, what happened at launch, or a little bit after that, or just give me absolutely everything. I know it's not specifically A/B testing because you're iterating different versions, but there is that, right? So put that to one side. Okay, we've got version comparison info out of the box. Now, with regard to A/B testing specifically,
So basically, customers do not do A/B testing using these views, but then they track the A/B
yeah,
testing results through these views.
yeah. Look, you might be interested in. I'm just sending you a link now in the chat. Just like, this is not about mobile as such, but it is just with regard to A/B testing in general, and I've sent it to all of you. You know, New Relic One is a programmable platform, right? So you can develop whatever you want on top of it. Now, what you might be interested in is we actually have an A/B testing app that, you know, we run. There's a tutorial there. I've given you guys the link to it. You can build out a React app for yourselves that will track A/B testing, right? Obviously, you will need to code it with specifically what you want to track and how you want to track that. But the framework is all there. So you may find that that is a useful starting point to build out your, you know, maybe a long-term A/B testing analysis, you know, application that will be customized specifically to your environment. So yeah, because A/B testing is generally very specific to the feature that you're wanting to compare. Like, well, I want to do this thing, and like maybe it's going to look like this or like that. So each, you know, each feature will look slightly different every time. But this way, you guys have got a framework. You can put it in place and maybe just, you know, plug in your features and then run testing against those too. So yeah, out of the box, I think it's a bit of a hard ask to get, you know, comparisons on a very specific feature. The other suggestion I would have would be you capture the other thing I would suggest, and again, be cool to get your advice on that, Ganesh, would be, so whatever your feature is that you've got the 2 different options on, or 3 different options or whatever, capture a custom attribute on the feature itself, so that when your user hits the load balancer and gets directed to the different options, you're then capturing specifically which option was invoked at that time. So then you get to check things, and you'll be able to do very simple queries on that later, where you can then go and say, well, what was my conversion rate when the color was blue versus when it was green versus when it was red, kind of thing. So I suppose if you wanted like a big full testing, like an A/B testing suite that you could build out for yourself over a longer period of time, I would go maybe explore the developer path, build out your very own A/B testing app in New Relic, which you can then plug your features into. If you want something a little bit quick and dirty, just to give you a bit more immediate results on the different values that you're wanting to trial, go in and apply a custom attribute. Yeah, just so that you can track the differences between okay, this transaction was invoked from this spot or from that spot, right? So you've got a differentiating point. Yeah, that'd be my advice on those things. Cool. I think I'm gonna grab your screen, Ganesh. Just gonna flick it over. So I want to leave you guys with this. This is, I mean, it's not like a big comprehensive lab or anything, but it will just get you logged into New Relic and run a couple of simple queries just so that you can see some of the data that's floating around in there. Yeah, the queries are here. I'm not going to paste them. I'd actually much rather you guys tab complete your way through. You don't have to type the whole thing, but just definitely get used to tab completing because it will fix, case sensitive problems that you will undoubtedly run into over time. Okay. So, any other questions, guys? I hope this was an insightful session, and hope that you guys gain a new perspective on real-time front-end monitoring or browser monitoring. Okay. Yeah, one question just came through. So what's the, yeah, how do we apply custom attributes from browser? Do you want to take that one, Ganesh?
Yep, sure. So just like how you have additional instrumentation on APM and mobile app, we also have custom attributes and events that can be reported from browser as well. Again, very few lines of code that you just have to add, and you would get those. I think I should. There is something called as custom attribute that you can add to page view kind of transaction. So basically, you just need to add. Let me just get the function right here, function name here. There's a New Relic set custom attribute function that you can use as part of the page action, and that would give you and that would send those data to New Relic One platform. I just gave you the reference to a documentation here. You can take a look at that.
Thank you. I asked you to take it because I was looking it up, but then my browser crashed, so I was going to send through the link for browser instrumentation, but yeah, I couldn't do it. my window just crashed on me. Like, oh, can you do it? Because I'll look it up while you're explaining it. But yeah, okay, guys. I think look, I'll leave this up on screen for the next couple of minutes. So yeah, screenshot it if you like. Feel free, and run through the lab. Oh, look at that! See, look now, this browser's crashed on me. See, look at that. I'm gonna reload it. Give me a second. It's right in the middle of. Oh no, it's not interacting with your queries. Let me pull it back up again. Chrome doesn't like me. There you go. All right. Hopefully it'll last for another 5 minutes. All right. I'll leave it there. But yeah, look, we'll go offline for now. So definitely looking forward to seeing you guys back here next week for our final session, where we will be going through some synthetics concepts, talking about a lot of things synthetics related, which should be pretty cool. Looking forward to seeing you back then. If you've got questions in the next couple of minutes, yeah, feel free to throw them in the chat. We're still going to be here for the next few minutes, but you know, our session's finished for today. So have a great week, have a good weekend, and look forward to seeing you all back here next Monday at 8:30 a.m. IST, 1 p.m. AEST, and 3 p.m. NZT, I think, and
Nice.
and 11 a.m. SGT. Yeah.
You know your time zones, Dan.
All right. I'll yeah, see you next week, guys.
All right. Thanks, guys. See you next week.